absolute value. So we're going to talk about equations and inequalities involving absolute value. Um, these equations could be different types. It could be linear. It could be quadratic. That's the two that we've learned so far, right? And then the inequalities, greater than, less than. Those are a little bit more difficult, but we'll talk about a way to hopefully make them make sense to you and so you can work them out. So first thing, let's talk about what absolute value is. So the absolute value symbol is more of an operation that's applied to a number. And we'll say that the absolute value of u is equal to a if u is equal to a or u is equal to negative a. The way that I like to think of the absolute value is a few different ways. So one way is what I have written here. Another way to define absolute value is the magnitude of a real number, which is a weird way to put it, but what that means is that it's how far a number is away from zero. So if you think about your number line, let's say zeros here, let's put 1, 2, 3, negative 1, negative 2, 3. Let's put a negative 4 in there. If we take the absolute value of 3, how far is 3 from 0? It's 1 unit, 2 unit, 3 units away from 0. So its absolute value is 3. You want to do the absolute value of negative 4? How many units is negative 4 from 0? 1, 2, 3, 4. So the absolute value of negative 4 is 4. Okay. It's the same thing I like to think of, like if you ask me how far is it to drive to Raceland, and I tell you it's, I don't know, that's probably going on here, but I say it's like 5 miles, right? And you tell me how far it is to drive to Lavityville, and I say that's 5 miles. Well, their distance that I would travel is equal, it's just in different directions, right? And so you can think of absolute value that same way. What is the distance from the origin? What is the distance from 0? And that'll give you the absolute value. Okay. Any questions on that? There's another way to define absolute value, and that's with a piecewise defined function. You can define it such that the absolute value of, well, let me just rewrite that. It looks so bad. The absolute value of x is equal to x if x is greater than or equal to 0, and it's negative x if x is less than 0. So basically you negate it if it's negative, and so does it become positive. And if you've ever seen we usually talk about this later in the semester, but why not bring it up now? The graph of absolute value, it's like a V. All right, so let's talk about solving equations. Now, the solving of the equations is easier, in my opinion, than the inequalities, and so these may seem trivial to you, but when we get to the inequalities, it may seem more difficult. So when we're solving equations involving absolute value, if you tell me that the absolute value of that algebraic expression, 3x minus 1, is equal to 2, I know that if I take the absolute value of 2, that'll give me 2. If I take the absolute value of what else, it'll give me 2. What other number? Negative 2, right? And so since the absolute value of 2 is equal to 2 and the absolute value of negative 2 is equal to 2, that means that what's in this absolute value, the 3x minus 1, could either equal 2 or negative 2. Yep, negative 2. At least it won't pop up right in the middle. There we go. And so now what we end up with is just two equations that we need to solve, two linears in this case. And so if we solve both of those, we add 1, we get 3x is equal to, oh, sorry, no, that's right, 3x is equal to 3, divided by 3, x is equal to 1. And for this one, have 1 to both sides, 3x is equal to negative 1. Divided by 3, and x will equal negative 1/3. And so this equation here has two solutions, 1 and negative 1/3. Any questions on that? All right, let's look at some other. Anybody still copying that down? I mean, I got here 4. Oh, thank you. All right, so let's look at this one. Finally, we have the absolute value of negative 2x is equal to 8. What two equations are going to come from that? Well, the first one's easy. I can do that one. We know that negative 2x could equal 8, or it could equal negative 8. Now notice that I just take whatever's in that absolute value, and that's what I put on the left-hand side or whatever side it was on. But I don't change that whatsoever. I keep that as negative 2x. And if we divide both sides by negative 2 here, we'll get x is equal to negative 4. And if we divide both sides by negative 2 here, we get x is equal to 4. So my solution set here will be the set containing negative 4 and 4. Oof. Any questions on that one? All right. This one. Number 2. What do you think we're going to do there? Got the absolute value of negative 2 times x is equal to 4. What's different about this one than the last problem? Anybody know? My variable isn't in the absolute value, right? It's just there. What's in the absolute value? Negative 2. Can we take the absolute value of just negative 2? What is it going to be? 2. So if your variable, or if a variable is not in the absolute value, just evaluate the absolute value. Take the absolute value, whatever is inside it. And so we just end up with the basic equation of 2x is equal to 4. And divide by 2. So x will equal 2. So those are kind of a trick problem there. Any questions on that one? I don't want to do 3 yet. Don't make it a whole problem. What if we have, let's say, 3 times the absolute value of x minus 1 is equal to 4. Do I want to take that immediately and say, well, that means that 3x minus 1 could equal 4, or 3x minus 1 is equal to negative 4? Why not? That's true. We don't know if the x is negative or positive. But remember, the real reason we want to do it is because we can't make that assumption about this whole thing, right? Because the only thing that the absolute value is on is just the x, which may be what you're talking about, right? You don't know if it's negative or positive. So what we want to do first is we want to isolate the absolute value before we make this step here. So you don't want to jump straight to that. What we want to do first is let's add 1 to both sides. So we'll have 3 times the absolute value of x is equal to 5. Let's divide by 3. So the absolute value of x is equal to 5/3. And now that we got the absolute value by itself, now we wanted to make that step and say, well, either x can equal 5/3 or negative 5/3. So get the absolute value by itself before you break it in, oh, not break it, but make it into 2 different equations. Any questions on that? And one last one I want to make up before we go on to this other one. I might do 2 more, actually. And the absolute value of 2x minus 1 is equal to negative 3. What do you think I need to do there? What can I take the absolute value of that'll give me negative 3? Nothing. So what do you think the answer to this problem is? No solution. If you have just an absolute value equal to a negative number, there's going to be no solution to that, because there's nothing I can take the absolute value of that'll give me a negative value. Yes, you only do the positive and negative, 2 different equations, when there's a variable in the absolute value. If there's not a variable, if it's just a constant, just evaluate that constant. And the other one that gives people problems, well, do I have one like that later on? Yeah, so we won't do that yet. All right, so let's look at these things. Do I have enough room? I'll just erase what I have to these. Don't have room. All right, number 3. We have 2/3 times the absolute value of x is equal to negative 1/2. What should we do there? What do you think?
Get rid of the fractions.
Want to get rid of fractions? Okay, that's good. I didn't even think of that. So what will we do to get rid of fractions? It's a 2 and a 3. It's a 3 and a 2. So when you find the LCM, that's going to be 6. So let's multiply both sides by 6. That'll be what? 4 times the absolute value of x is equal to negative 3. What should we do next? You may see the answer at this point, but if we want to be consistent, we want to get the absolute value by itself, right? Let's divide both sides by 4. And so with the absolute value of x, you get a negative 3/4. So if you have the absolute value by itself is equal to a negative number, what does that tell us? No solution. Now, from the beginning, you may say, well, it was equal to a negative at the beginning. Can't we just assume that it's no solution? You got to be careful. Because what if the problem was negative 2/3 times the absolute value of x go to negative 1? That one does have a solution. Okay. So you need to be careful and get the absolute value by itself before you make that next step. Any questions on that? Let's see, before we do 4, what if you have, let's keep it simple. Oh. Let's do minus 9. Sure. We'll probably do a fraction. That's fine. This is one that people miss a lot. Just throughout my career teaching this. And so what they see is absolute value on the left-hand side, negative number on the right-hand side. And so they go, no solution. But remember, before we jump to that, we want to get the absolute value by itself. And if we do the step to do that, which is going to be adding 9 to both sides, we'll get the absolute value of 3. Sorry about that. Stop registering my marker. We're going to the absolute value of 3x plus 6 is equal now to 6. And now you end up with the absolute value is equal to a positive number. So now you can make those next two steps of either 3x plus 6 is equal to 6 or 3x plus 6 is equal to negative 6. Which this one's going to give us what? 3x is given 0, so x is going to equal 0. So give us 3x is equal to negative 12. This worked out well. So x would equal negative 4. And that is just a really bad 0 right there. Negative 12. The 6 we making. Any questions on that? Yeah. Don't want to do 4. I guess why not? I'll give you all 4 to try. I'll try this one on your own. You have the absolute value of x minus 2. No, try it again. The absolute value of x divided by 2 minus 1 over 3 is equal to 1. So give that one a shot. And then we'll go over it. Everybody's still working on it. Sure. All right, so this one's pretty straightforward. Well, I mean, it's beginning straightforward. You have an absolute value on the left side and just a constant on the right-hand side. So all you have to do, since it's already set up, say, well, x over 2 minus 1/3 could equal 1, or x over 2 minus 1/3 could equal -1. Either one of those will result in the absolute value being 1. And so now we just got to work out both of those. To get rid of the fractions, just like before, we can multiply by 6 on both sides. And so we end up with 3x minus 2. Make sure you distribute that 6 for sure, is equal to 6. Or, do this one as well. Same time, we'll get 3x minus 2 is equal to -6. And so if we work that out, add 2 to both sides, 3x is equal to 8. And divide by 3. So x would equal 8/3. Then this one we'll add 2. We'll add 3x is equal to -4. Divide by 3. That's our 2 solutions there. Any questions on that one? So the big thing I think is, just set it up correctly. And then remember to distribute the 6. A lot of people won't distribute it to the 1/3. They'll just put like a 1 there rather than the 2. Or forgetting to do it on the other side. That'll happen. All right. Should have some more examples, or did I get move those up? Yep. Maybe so. Oh, there they are. I knew they were there somewhere. Trying to set it up so they were smaller, but they look too small. I have to redesign it. All right. 5, we got the absolute value of u minus 2. That's all in the absolute value. Is equal to -1/2. What's the solution to that one going to be? No solution, because you can't have the result of an absolute value equal to a negative number. So we got the absolute value isolated already. It's equal to -1/2. There's nothing I can put in there that will give me that. Number 6, you have the absolute value of 1 minus 4t plus 8 is equal to 13. We don't have the absolute value by itself now, so we want to get the absolute value isolated. So to do that, we're going to subtract 8 from both sides. And so we'll end up with the absolute value of 1 minus 4t is equal to 13s and 8s. Is that 6? No, it's 5, huh? Yeah. And so now we have the absolute value by itself, isolated, equal to a positive integer. Not non-negative is really what I should say. So we can say 1 minus 4t is equal to 5, or 1 minus 4t is equal to -5. And then we'll solve that up. Subtract 1, -4t is equal to 4. Divided by -4. And so t will equal, we need to put it somewhere. We'll keep it there. T is equal to -1. And if we work this one out, -4t will be equal to -6 divided by -4, which will be 3/2. And that'll be our solution there. Questions on 6? Seven, I want to rewrite. I'm going to do the absolute value of 1 minus 2x minus 6 goes negative 1. What are we going to do there? We're going to add 6. We're doing that so we can get the absolute value by itself. So if we add 6 to both sides, then the absolute value of 1 minus 2x equal to negative 3. And what can we do from there? Nothing. Why? There's no solution. You got an absolute value by itself equal to a negative value. No solution. No real solution. But in this class, we're just talking about real numbers. No real solution. And the other 7 was straightforward, so it's the same as 6. So I don't think we need to look at it. But 8, I do want to look at it. All right, so we got the absolute value of x squared minus 9 is equal to 0. The absolute value is by itself. So this is usually where we make it into 2 equations. It's a quadratic. Not that big a deal. But do I want to go ahead and say, well, x squared minus 9 equals 0, or x squared minus 9 is equal to negative 0? There's something wrong with that, or what?
You can't have a negative.
Yeah, there's no such thing as negative 0, right? Negative 0 is just 0. 0 doesn't have a sign. So all we need to do is say, well, x squared minus 9 is equal to 0. So if you have an absolute value equal to 0, you just got to set it equal to 0. And hopefully, well, notice all this. You can either factor it or use my preferred method, the square root method. And it's going to be plus or minus square root of 9. So x is equal plus or minus 3. Positive or negative 3. Any questions on that? So just a overview. Isolate the absolute value by itself. If it's equal to a negative, no solution. If it's equal to 0, say equal to 0. If it's equal to a positive, make it 2 different equations, the positive and negative. If there's no variable in the absolute value, just evaluate the absolute value and solve from there. Is there anything else I'm missing? You can always check your answer, but it's not necessary here. Like the radicals, you shouldn't end up with extreme. Let me make sure before I say anything. You shouldn't end up with extraneous solutions. Yeah, y'all probably won't see anything like that. The only reason I could see is if there was an x on the, if there was a variable on the opposite side of the absolute value, we need to get some dangerous walk, but y'all won't see anything like that. All right. Any questions on the equation part? All right, so hopefully you understand that. Now we're going to get into the more difficult part here. Oh, let me zoom out so I can see where my notes are. Okay. That's the problem with zooming in. It helps my hand right now better. Okay, so remember we said that, or I said, that the absolute value of a number, you can think of it as its distance from 0, its distance from the origin. So if we have a question that says that the absolute value of x is less than 4, what's that saying is that the distance x is from 0 is less than 4 units. So it can be 4 units in the positive direction, or it could be 4 units in the negative direction. So when you see this and it's saying the absolute value of x is less than 4, you end up with this range of numbers that it can be, this interval of numbers that it can be. Notice that there's a lower bound and an upper bound, right? And it's all one continuous interval. So when you have the absolute value of x is less than 4, what that becomes is that x is less than 4, but it's also what? It's greater than -4. So it's bound by -4 and 4. It becomes a combined inequality. Any questions on that? So, if you have a problem, I don't like that. Let's do this. The absolute value of x plus 3 is less than or equal to 8. I should have chosen a smaller number. There we go. It's fine. What that's telling us, I'm just going to draw 8, is that x plus 3, oh, I messed up. Is in this interval here. It's between -8 and +8. And the reason I put brackets is what? It has the equal to on my inequality. So it's going to have an upper bound and a lower bound, and that is going to be x plus 3 is less than or equal to 8. That's also greater than or equal to -8. So my absolute value inequality, or my better way to say it, the inequality with an absolute value becomes a combined inequality here. And we just solved that like we learned in 1.5. We're going to subtract 3 from all the parts. I knew it was going to get another something. And we'll end up with, what, -11 less than or equal to x, which is less than or equal to 5. And so that means that x has a lower bound of -11, including -11. It has an upper bound of 5, including 5. So the interval notation would be -11 to 5. With brackets, because it includes. One thing about these, you shouldn't end up with a half open, half closed, because whatever the inequality is, if it's equal to or if it's not equal to, that should be replicated on the other side that you create. Okay? So if you do end up with a half open or half closed one for this, you might make a mistake. Any questions on that? Okay, so notice that both of them we did were less than. What if it's greater than? So remember I said that it's the distance away from 0. And when we did that, x was the absolute value of x was less than 4. That means it was less than 4 units from 0, so it's bound by 4 and -4. When we say that the absolute value of x is greater than 3, it's as though you're jumping more than 3 units away. So you're jumping further than 3 in this direction, so it's all of these numbers, or you can jump in this direction. So the big thing is, what's the difference between that number line and this number line? What's the difference between this number line from this number line here. On the 4 one, I'll draw it real quick. It's all one interval, right? But for this one, it's 2 separate intervals. Okay. And so to set up that one there won't be a nice combined inequality. It's going to be either x. So let's talk about this one first. How would you write this as an inequality? What would y'all do? X is greater than 3. Oops. Sorry. And how would you write this one here? Close. X is less than -3. So they don't have a shared region, so I can't combine them together, right? Because if I say x is greater than x is greater than 3 and x is less than -3, there's no numbers in that. So we have to write it as 2 separate inequalities. If x is greater than 3 or x is less than -3. Any questions on that? So people try to memorize it, and that's fine if you want to go that route. But if you do end up with the absolute value of an x expression or a variable expression is greater than a number, it should be 2 separate ones. If it's less than a number, it should be 1 combined inequality. There are some times where that's not the case, but for the majority of numbers, that will be true. And we could talk about those special cases later. Okay, so next, well, any questions here? How do we write this solution as an interval? Just focus on it in pieces. How would you write this in interval notation? X is less than -3.
Negative infinity to negative 3.
Negative infinity to -3, and we're going to put a parenthesis on the -3 because it's not equal to it. How will we write this one? Interval notation.
3 to infinity.
3 to infinity. And we put a parenthesis on the 3 again there because it's not equal to it. How do we combine those together? We can do the union. And I think I talked about the union already. So that's saying that it's either in this interval, the union means, or this interval. Any questions on that? All right. I believe the next thing's on the next page. Yep. We kind of did that already. So let's just start on these. Oh, you know what we should do then? Yeah, let me give y'all one first, and then I'll give y'all something to try. So what do we have? The absolute value. Oh, that's such a nasty problem. I'll make up my own. Of 2x plus 2 is greater than or equal to 6. How are we going to set that up? If you ever get confused of like, okay, well, is this going to be one combined inequality or 2 separate inequalities? I'm a big believer in number lines, and you probably know that already. But if it's saying that it's greater than or equal to 6, sorry about that. That means it's either here That's where 2x plus 2 could be. Or it could be this way, greater than 6 units away from 0. So if you end up with two separate regions or two separate intervals, you know it's going to be two separate inequalities. If you end up with one region, one interval, then you know it's going to be a combined inequality. So we know this one's going to be 2x plus 2 is less than or equal to negative 6, or 2x plus 2 is greater than or equal to 6. And then we just solve those up. So subtract 2, we'll get 2x is less than or equal to negative 8 divided by positive 2. So my inequality doesn't need a switch, it's positive 2. And so x is going to be less than or equal to negative 4. Here I'll subtract 2, so 2x is greater than or equal to 4 divided by 2. And x is going to be greater than or equal to 2. Questions on solving those. So once we solve it, how do we write those in interval notation? Negative infinity to negative 4 with a bracket because it would be equal to it. Union bracket 2 positive. Any questions on that? All right, so let's talk about, we got what, 8 minutes left? Let's talk about some interesting scenarios for this. What if I have the absolute value of 3x minus 1 is less than negative 1? What do you think I need?
No solution.
Why is it no solution?
Because absolute value can't be less than negative 1.
Yep, so whatever is, we take the absolute value of, whenever you take the absolute value, it's always going to be greater than or equal to 0, right? It's equal to 0 if it is 0, and it's greater than 0 for all the rest of the numbers. And so there's nothing that I can take the absolute value of that would make it less than negative 1. So this will be no solution. And that's interesting. That might be outside the scope, but let's do this one. What if you had the absolute value of 4x plus 5 is greater than or equal to 0? Remember, we're talking about in this class, just the real numbers, right? And so the real numbers you can break it into three sets. It's kind of the easiest way to think about it. You got your negative numbers, you got 0, and you got your positive numbers, right? And we know that the absolute value is everything but the negatives. When we take the absolute value of a number, it's either going to be 0 or greater than 0. So no matter what, hey, give me my mark, is in here, when I take the absolute value of it, it's going to be what? It's going to be positive or 0, right? It's going to be non-negative is the term we like to use. So it's going to be greater than or equal to 0 no matter what is in there. And so the solution to this one is going to be all real numbers, which I believe in our textbook is denoted. Let me pick up the top slide right there. Negative infinity, positive infinity. So no matter what you put in there, it's going to be greater than or equal to 0. So put whatever from there. It gets a little tricky when you say that it's just greater than 0, because you have to take away what would make it 0. So, but like that's what I was talking to myself about earlier. I was saying, well, that might be outside the scope of the class. Yeah, that's probably outside the scope of the class. So those are some weird scenarios you might see. I don't know if you'll see them in the homework or anything we do, but it is possible. This one, no. So just be aware of it. I like to show you anything that's interesting.